Designing your own parts to be 3D printed is one of the coolest things you can do with a 3D printer, but if you don't know CAD, it can be intimidating to get started. I have this drawer that I designed for my friend, and I'm going to show you how I did it in Fusion 360 from start to finish, so hopefully you can learn to create your own designs. I'm Jacob from Butter Pockets, and let's get started. Before we get into Fusion 360, I wanted to show you guys a prototype and explain the overall design I had in mind and why I did it this way. So you can see that I did this in multiple parts, and I did that for a few reasons. The first one is that you can print this on a printer that can only do one filament at a time, and you can do multiple colors. The second is so that way you don't have to print two huge prints. You can print multiple smaller prints, shorter prints, so that way you can decrease your risk of failure. And the third is so that there's just no overhangs anywhere. You can see on the front that I did a lip on the top, sides, and bottoms. And if I had printed it as one big print, the whole entire bottom would have just been an overhang. I did the design with dovetails, so that way the pieces can snap together. And you can see that these snap together pretty good. And they don't come apart. You could have just done regular rectangular joints, but you would have had to have used glue if you did that. And this is an easy way to print this with no overhangs, and the pieces can just snap together. And that should give you guys a background on why I did certain things the way I did, and will help make what I show you in Fusion 360 make more sense. Now that we're here in Fusion 360, I want to start off by saying there's definitely going to be some better ways to do this stuff, but I want to show this to people who probably have never used Fusion 360 before and are just starting to get into it. So one of the things that I did when I first started was I tried to only use these simple shapes like boxes and cylinders. I tried to draw these and manipulate them, and it's best to go ahead and get rid of that habit and start working with parameters and start working in sketches, because it's so much easier to draw in 2 dimensions and extrude it than it is to try to manipulate these 3D objects. And it's best to go ahead and get used to doing parameters so you can parameterize your models and you can change things on the fly even after you're already done. So the first thing I'm going to do, and you might find it easier to do this as you go along, but I've already got them ready, is add my parameters. So I'm going to add a few parameters here and I'll explain them afterwards. Okay, now that the parameters are added, let me explain them. So front width and front height are going to determine the height and the width of the drawer itself. Thick is going to be the thickness of all the walls, except some, and I'll explain that in a second. Off 1 is something I use in all my designs. It just stands for offset 1. And it's usually 0.1 millimeters, and I'll do off 2 for 0.2 or off 3 for 0.3. Bottom length is the length of my drawer. Dist to bar is the distance from the front of the desk to the bar that's under his desk, the reason we're making this drawer. Height to bar is front height minus 48, so the bar sticks 48 millimeters off the desk, and this is going to be the difference between the front height and the bar height. Dove is going to be the parameter that I'm using for my dovetails. Bot thick is going to be 4 millimeters, and the reason I do bottom thickness and thickness is because I ended up putting magnets in my bottom to help it keep open and closed, and if we do 3.6 it's too thin for the magnets, so I do 4. And dang is going to be the degrees that I use for the dovetails, dovetail angle, dang. Another thing to think about is when we do these thicknesses, I know these are going to be in the z-axis, and I usually do them in 0.2 increments because that's what I normally print out as 0.2. I also wanted to show you guys the actual final thing so you can understand what I'm talking about. I went ahead and modeled the desk and the bar so that way you could see the bar here, the desk here, and the drawer as it slides in and out, and how it has to miss this bar. I'm not going to fully go over how to get from 0 to here. There's going to be some I leave behind, and I can make a part 2 if you guys want to see that. Okay, now that we have our parameters saved, we're going to go ahead and start a sketch. So I'm going to sketch in the YZ plane for the front. The first thing I'm going to do is I'm going to make a rectangle that just defines the front of my drawer. So this is going to be height by width. And then, as I explained, I want the outside of the front to have a kind of lip that hides things. So we're going to do rectangles on the sides that are going to define those. I'm going to start with the top and the bottom, and I'm going to make this bottom thick by front width. All right, now we need to define the sides. These are going to be a little different because they have to be thick plus dove in thickness because of the rails that the drawer rides on. So I'm actually going to anchor these to the bottom rectangles that we already drew. And they're going to be front height plus 2 times bot thick. And they're going to be dove plus thick in the Y dimension. Now that those are defined, I'm going to finish these corners in and we can just draw rectangles. Okay, I want the front to have a pull tab as well. So what I'm going to do is I'm going to define halfway across the top by doing front width over 2. Now that that's defined, I'm going to draw the trapezoid that I can extrude for that. So we're just going to draw a trapezoid and it doesn't matter what the dimensions are. And then once we're here with our dimensionless unconstrained trapezoid, we're going to hit D on our keyboard and it's going to come up with the sketch dimension. So what you're going to do is I'm going to define the angles, I'm going to define the distance, and I'm going to define the bottom. So you can click on each side and you'll define an angle. We're going to make that dang 60 degrees. We're going to do the same for the other angle. I'm going to define the distance between the top and the bottom. And for the pull tab, it's actually kind of arbitrary. It's whatever you want it to be so that your fingers fit in. You can pull the drawer out. I just made this 19 millimeters. And then same thing for the width. I just ended up making this 40 millimeters. And then now that this is constrained, we're going to hit escape and get out of this. We're going to hit this midpoint tool. We're going to click the top, and then we're going to click where we defined this midpoint to be, and it's going to auto snap the midpoint of the top of the trapezoid to the midpoint that we defined by this front width over 2. The last thing that we need to do for the front is we need to define the sketch for the rail of the dovetail that rides along the sides. And the reason we're doing that in the sketch for the front is because it goes along the side, and we're going to extrude the sides themselves into the page in the Y dimension, whereas these go into the page in the X dimension. It'll make sense later when we actually extrude it. So we know that the overall height of this drawer across the length of it is height to bar. We can see that here. This distance right here is height to bar. And that's because overall the drawer can only go this high in the drawer and where the bar is. So I'm going to define height to bar over 2. And that'll give us a midpoint for that dimension. And then I'm going to draw another trapezoid over here. It doesn't have to be perfect. We're going to define those constraints. We're going to define the angles. We're going to define the distance. And for all my trapezoids, the bottom, I just define them as 2 times dove, so 10 millimeters. And then I'm going to snap the midpoint of the bottom to this one because we want it to ride along. And you can kind of see what I mean, how the front is going to have this extrusion, and that'll be on the sides, and this will be the dovetail, and then this will be the joint that it rides on, and you'll see that later. Okay, the front is done, and we can go ahead and finish this sketch. I wanted to explain how I fixed this. So if you noticed, part of the drawing was blue, which means it was unconstrained, and it was because when I had defined this original bottom rectangle, I guess something got messed up with this dimension here. So I just had to go through, double click, delete this rectangle, delete this rectangle, and delete these two. And then just redraw them the exact same way I did in the video, but properly make sure the dimensions are applied so that it's constrained. And you can see now the full sketch is black, so it is properly constrained. Now we need to define the sides. And I'm going to go ahead and hide the front. And we can name this too. Okay, the side is going to be a little bit more complicated, but we're going to start off by just drawing a rectangle that is front height, and this is going to be dis to bar. And we're going to finish the profile of the drawer by drawing a rectangle that is bottom length minus dis to bar. So that way the whole length is bottom length, and then this is going to be height to bar. So now we can see the profile of the drawer coming along. And then I'm going to define two rectangles that are both going to be bottom thick in the Z dimension that are going to define the bottom of the drawer and the bottom of the mount. So these are going to be bot thick, bottom length, and this is going to be bottom length plus 1 thick to account for the back of the drawer. And that one of those is going to be within the constraints of the actual side, and then we're going to extend the bottom to make room for the actual mount of the drawer. Then I'm going to define where these dovetails are going to go along the bottom. So I'm going to define bottom length divided by 8 to have 1/8 of the way. I'm going to define bottom length over 2. And I'm going to define 7 times bottom length over 8 to have 7/8 of the way across. Now that we have those defined, let's draw the dovetail trapezoids that are going to be for the side of the drawer to mount to the bottom, as well as the side of the mount to mount to the bottom of the mount. So we're going to draw 6 identical trapezoids, and we're going to define them the same way we did before. Except they're going to be bottom thick in the Z direction. Now that we have the one, we can just copy paste it and make 6 of them. We're going to use the same midpoint tool, except one of them is going to go on the top of these definitions and one of them is going to go on the bottom. So we're going to do one on the top and one on the bottom, like this. Okay, now those trapezoids are defined. Now we're going to define trapezoids for the front that's going to mount the sides of the drawer to the front of the drawer. And it's also going to help us create the mount themselves for the front of the drawer to mount to the side of the drawer. This needs to have some thickness to it, so we're going to start at the origin. And we're going to define a rectangle here that's going to be front height. And the distance is going to be 2 times dov, because I want these to be that thick. Then we're going to define 2 distances here. One is going to be front height over 4, and one is going to be 3 times front height over 4, so 3/4 of the way up. Now you can see we have these definitions here. Again, we're going to draw our trapezoids. Again, we're going to draw our trapezoids and define them the same way we've been doing. These ones are going to be 2 times dov in height. We're going to copy and paste this. Midpoint tool, snap them. Okay, now we're going to define the dovetails that will hold onto the top of the mount, so they will exist outside this boundary of the side of the drawer, so above. So we're going to do the same thing. We're going to define dis to bar over 4, and we're going to define 3/4 dis to bar, because if you remember, this top is dis to bar long. All right, we need new trapezoids, which are the same as these, which we should have just copied 2 more from here, but we can just draw them again. Bot thick is also used for the top. That's why these are also bot thick. We need to finish this section for the back of the drawer. So we're going to draw this triangle, or this rectangle. It's going to be thick, front height, or height to bar. And then just like we did in the front to define these trapezoids that'll become the dovetails, we need to do the same thing for the back. So from here, I'm going to define one that is height to bar and 2 times dov. I'm going to define half height to bar, and then I'm going to draw my trapezoid. Okay, that finishes our side sketch. Now let's sketch the bottom. This is going to go in this plane, and this one's going to be very simple. So we're going to sketch front width by bottom length Then we're going to do the same thing that we did on the front and the back of the side and define some dovetail trapezoids that are going to go in the front and the back. So we're going to define the rectangle that encompasses them. So it's going to be front width 2 dov. I'm going to define those midpoints, so 1/4 and 3/4, and then draw the trapezoids. Don't worry if this happens, this over-constrained sketch. You can just cancel and delete this. It just means you snapped it to the grid and you gave it too many constraints. All right, now that we've done the dovetails for the bottom, we're done with the sketches. The next thing I should do is define a construction plane, which is just going to be an offset plane that we can use to reference things and especially mirror things. And I'm just going to define it as front width over 2. So that way we can mirror things across this plane. All right, now we can actually start extruding. So I'm going to show just the front and I'm going to extrude the front. So for here, we're going to select everything except this pull tab. And we're going to extrude this thick distance. After we've extruded the front, we can rename it. All right, so we call it drawer front. Then we're going to extrude the side. So I'm actually going to hide drawer front, show the side sketch, and extrude. And since we know the side is going to be full of dovetails, we're going to extrude like this. So these dovetails are for the top mount. All of this is for the mount as well. This is going to be for the back. This is for the front. So we're just going to extrude the side section and the dovetail sections. We're going to extrude these thick distance. And to make sure it's a new body, we can rename this one to drawer side 1. Then I'm going to extrude the dovetail that's going to make the railing. So we're going to hide our bodies. We're going to show our front sketch. We're going to extrude just this dovetail section. We can show our side again. We're going to do it in an offset plane, and we're going to start it at -2 dov, because we want it to start after this dovetail. Then we're going to extrude it back the length of it, so minus bottom length. We can see that it starts at the right spot, but it extrudes too far because we need to account for the distance of both of these dovetails. So bottom length is too far, so we need to add 4 times dov. Because we already offset it 2 dov, we need to re-offset it another 2 dov, so it's 4 dov. And we're going to make sure we select join here, so it joins to drawer side 1, and drawer front is not selected, so it won't join to that. We can just go ahead and mirror it to the other side. So what we're going to do is create mirror. Objects, we're going to select the drawer side. Mirror plane, we're going to use that construction plane we did earlier. And it's going to be a new body, and we're going to hit OK. So now we've got 2 sides. We can rename this to drawer side 2. So now you can see we've got a front and 2 sides, but the front doesn't have the sections that these dovetails are going to slide into. So I'm going to hide these, and I'm going to show side. I'm going to hide front sketch, and we're going to extrude what is going to attach to the front for those dovetails. So we're going to extrude. We're going to extrude what we didn't extrude earlier. And we're not going to extrude this part just yet, because for here, we're just going to do thick. We're going to do join. And you can see we made one side. And now we need to make the other side. So what we're going to do is extrude the same piece on an offset plane. The offset is going to be front width. And then you can see if we extrude negative thick, we'll get the same thing on the other side. Then to finish it out, we'll extrude the bottom. This will be front width. Again, join it. And you can see this is almost done. We just need to leave the dovetails for the bottom. So what we're going to do is we're going to show sketch 3, which we forgot to rename to bottom. And I'm going to extrude these out. You can do bot thick because you know precisely that this is bot thick. You could also choose to do this as all, and it'll just cut all the way up since there's nothing above it. But I'm going to choose to do it by defining the distance. Okay, and now our front is fully done. And you can see that the sides slot in. They're exactly the correct distance, so you can't really see where they slot in, and we'll fix that later. Let's go ahead and make the back. So we're going to show the side again, and we're going to extrude the back, which is going to be this thick section back here. This is going to be front width. It's a new body. We're going to do the same thing for the back that we did for the front in order to create the dovetail section. So extrude the negative, do it again on an offset plane. That is front width. Extrude it in the negative thick, and then extrude the bottom all the way across. Then we can extrude the bottom dovetails out like we did on the front. The back is complete, and then we'll extrude the actual bottom itself. So extrude all of these. And remember, don't include this negative space that will hold the dovetails in. This will be bot thick. And make sure you select new body or hide all your other bodies. And at this point, we have a full drawer. And there's the drawer with the dovetail slides. I know it looks like all one piece right now because we cannot see the definition of the, I mean, you can kind of see them, but we'll fix these offsets later. I find it easier to do that once we hit components. So now let's make the mount for the drawer. So we're actually going to hide all of these. I'm going to show the side sketch. Now we can go ahead and extrude the sides of the mount, which is everything that the drawer sides doesn't have. It doesn't have these dovetails. So we're just going to extrude everything. But like the drawer, the bottom is just the dovetails and the top is just the dovetails. And then for this, we're going to extrude it the other way. So we're going to do minus dov minus thick. And then I'm going to rename this to mount side 1. And the reason we did that thickness the way we did it is if we show the drawer side 1, we know that the dovetail is in there and it's going to slide through. So it needs to be as thick as this plus some extra thickness so that this doesn't just cut through the whole thing. So what we're going to do is we're going to show the front sketch. We're going to hide the body and we're going to extrude this back out of it. And then I'm just going to extrude this all and flip the direction and you'll see it cuts through the whole thing. And you can even check the objects it's cutting and you can see it's cutting mount side. So we'll just do that. Okay. So you can see that we've got the channel running all the way through. If we show the side, you can see that it fits in there nice and perfect. And you can see that they snug up. So now that this one side is defined, we can go ahead and mirror it to the other side. Select the side, select the mirror plane. It's going to be the construction plane again. Okay, so now that that's done, we just need a top and a bottom and we're almost done. So for the top, the way I'm going to do that is I'm going to use the front sketch and I'm going to define it back. So we can extrude here. We're going to define this as minus dist to bar. We're going to do new body. We can rename this mount top. To finish this up, we need to subtract these dovetails from the mount sides out of it. So we're going to do combine. Our target body is going to be the top itself. Our tool bodies are going to be the mount sides. And you can see that it's going to cut them away. But if we don't check this box, keep tools, they'll just go away in the combination. So let's check this box, keep tools, so it'll subtract the difference from them. And you can see that it's defined, but we get to keep the sides. Now let's define the bottom. We're going to do the same thing that we just did with the front sketch. We're going to extrude the bottom. Actually, it looks like I forgot to draw one of my rectangles on the front sketch, so that's no problem. We can edit our front sketch. And this is going to be the whole bottom. Make sure it's a new body. And it's actually going to be plus a thick as well. And then we can rename this mount bottom. And then we're going to do the same thing we did to get the dovetails out of the bottom. So our target body is mount bottom. Tool bodies are going to be the sides. We're going to make sure we keep our tools. And we're going to hit OK. And then you can see how those cutouts are defined. And there you have it. We've extruded all of our bodies. So now what we're going to do is we're going to set up some components, and we're going to start to define the assembly. We're going to define some motion, and we're going to finish this thing up. So then I'm just going to select everything and turn them into components. And then I wanted to show you guys that pre-defining these rigid joints, that the model is parametric. You can change these parameters as you see fit, and the entire model will update. Everything is still intact, and everything just changed based on the dimensions that you defined. These rigid joints do get a little messed up. There's probably a better way to do it. And really those joints are just if you want to animate the motion to make it look fancy. You don't have to do that. And then we're just going to assemble this thing. So I'm going to hide all of the mount pieces. Now we just have the drawer pieces showing. And then what I'm going to do is assemble them. And I'm going to do this before we do anything else because we've got nice right angles and it's really easy to define. So if we come in from this direction, it's easy to see. Then we can hit this button right here that's for a joint. And what we can do is we can take one of these and something else, and we're going to define them all together. So if we click on this corner, and if you look, this is kind of showing you the direction of the different axes. And you can see that it's a circle on the YZ plane. And that's fine. It doesn't really matter which way we define it. See, we can change it here. We just need to define it one way and then click on the next component the same way. And you will see you just defined a joint between these two components. For this motion, if it changes, just select it as rigid because you don't want these to move, and everything is good there. Go ahead and do that for every piece of the drawer to define it as one rigid object. All right, now at least one component is defined to another component of the drawer, and since they're all defined together, this is now one rigid piece. Let's do the same thing for the mount. I'm going to show just the mount pieces, and I'm going to do the exact same thing where I'm going to assemble one to each other, and they will become one rigid thing. Now that the mount is done, we can assemble some motion in between the drawer and the mount. And it doesn't really matter where you define these joints in this case, so long as you define it in a full circle, so that way each component is somehow attached to the other one, and they're just one rigid piece. So now that we have the drawer and the mount defined as their own rigid components, I'm going to hide everything except the drawer front and the mount top. And then we're going to define a motion joint between the two. So we're going to assemble a new joint. We're going to select drawer front first, the mount top second, and we're going to go into the motion tab, and we're going to hit slider. And you can see it might select the wrong axis, and that's okay. Select the X axis, and you'll see it starts to move in the correct direction. And we can set up some limits if we want. The minimum is obviously going to be 0. And the maximum is going to be how far we defined the dovetail that it slides on. So if you remember, we defined that as bottom length minus 4 times dov. We can hit OK. And then we can just show every component. And we can expand our joints. And we can hide all these rigid joints. We don't need to see those. And we can just see the slider joint. And then if you double click this little joint icon here, you can move your drawer. And look at that. We've achieved motion, and we can see the final product that we tried to define, and it's all starting to make sense now. So you might think that we're done, but in reality what we need to do is we need to define some offsets. We need to add some fillets to these and round them, and then we can be done. So the first thing I like to do is offset all my faces, because if you try to offset your faces after you add your chamfers and fillets, it doesn't really work correctly. You could have done your offsets in your sketches, but I find it easier to do it once they're actually 3D objects. So what I'm going to do is every place that there is a dovetail, I'm going to offset each of the 3 faces of the dovetail by off 1. So to show you what I mean, I'm going to go into Modify, Offset Face. I'm going to select the outside and the 2 sides, just like this. And I'm going to select every one of these dovetails. So it's kind of annoying and kind of a long process. There's definitely easier ways to set this up previously in the bar. You could have done this at earlier steps, but I find this to be the most straightforward and easy to understand. So I'm going to go through and I'm going to select every face for a dovetail, except the drawer dovetails. We're going to do those separate. Okay, and if you did happen to be following along, there's dovetails on the sides of the drawers, the sides of the mount, the drawer bottom, and that's it. It was 78 faces for me. So we're going to do negative off 1 here. And this is just so the dovetails will actually snap into each other and not be too big. I found that an offset of 0.1 millimeters works well to get dovetails that snap together, but still have a little bit of play. And it's important to remember that if you're going to do it this way, it needs to be in the XY dimension on your printer. If you try to do it in the Z dimension, so like if you tried to print it in this orientation, you're probably printing at a 0.2 millimeter layer height. So if you try to offset it by 0.1, it's not really going to work. And then I define for the drawer sides, these rails, I do an offset of 0.2. So same process, but just 0.2. I find that 0.2 still fits together pretty well, but has a lot more room to slide. So now that we've defined our offsets, if we show everything, you can start to see that there is an offset here in all the joints, which is good and will allow them to snap together better. Now that we've defined these offsets, you have to go through and start to fillet and chamfer all your edges. I'm going to fast forward through a lot of this. It's very tedious. I'm sure there's a better way, but I just do it one piece at a time. And I'll do this one piece, and then I'll show you afterwards what I did. So any piece that references a dovetail, I did 0.5 millimeter fillets. I found that this works for me. You might find that you need a different value. The important thing is to do everything in the Z direction. For pieces like this, we're actually going to print this so the Z direction is up, and these will not be in the Z direction, but I did every corner that interfaces a dovetail as 0.5 regardless, no matter which piece it was on or which direction. Within the same piece, you can add more than one dimension as well. For all of the outside corners, anything on the very outside of the print, I did 1 millimeter. And now that we've done this one piece, I have to go through and do every single piece, every single corner. The only other spot I did differently were these corners, these two, on the mounts and the sides. I did these as 10. All right, now that I did all that, we can show all the components. And you can see that all of these edges are nice and rounded. There's a lot of spacing, and these components should fit together well. You can see that where it slides, there's even more spacing, and it should be able to slide. And overall, this is printable and multi-piece now. We can do some stuff to make it look better, we can modify our physical materials if we want. And the way I do that is I just do plastic. I just pull in this ABS one, and I'll change the color based on what I want it to look like. So I'm going to print this in mostly black. And I'll pick one that just kind of looks similar to one of my filaments. Then you just drag it onto the pieces. And if you want to do it in multicolor, you can right click on it, duplicate it, edit the color of the second material. We can do purple. This is similar. So maybe we do the sides in purple or something, and we can do the bottom of the mount in purple. Who knows? And there you have it. This thing is designed, and you could print it as it is now, and it should work. You might have to change some of the tolerances, you might have to change your offsets, but this is what worked for me. And I know that this seemed long and tedious, but the first time I did it, it took me a while, and designing this for this video, putting it in a concise way, really only took me about an hour and a half. The last thing I want to show you is how I did the sketch on the front, and I'll show you that in my other model. As far as putting these hexagons in, I can show you guys that in another video, but I'm not going to do it in this one because I feel as if this one's probably already a little too long. The sketch I'm going to show you here, already done in this timeline. So what you do is you actually insert a canvas. So you can go up to this insert canvas, and when you do that, you can select a picture that's on your computer and you can put it onto the face of a component. So you can see I put it on the face, and the picture just kind of exists there. It's just a JPEG file. And then what you can do is do a sketch on top of it. And someone please let me know if there's a better way to do this, but this is what I do and it totally works. All you do is in your sketch, I use this fit point spline and I just trace along the sketch. And if you need to adjust these, you can edit the curvature. And then what I do is I just take this sketch and I extrude it. And you can see I just extruded a body. I extruded it 0.4 millimeters, 2 layers thick. You could do 0.6, 3 layers thick, whatever you want to do. I leave it as a separate body on purpose, so that way when I export the drawer front, it has 2 separate bodies, and that lets you paint it a little bit easier, because then you can just hide the drawer, show only this body, and paint it in the slicer very easily, versus trying to actually paint it yourself. You can just use the bucket and dump it, and it'll just automatically select all of this and paint it. The last thing I wanted to show you guys is actually how I export this. So I will actually hide everything except one piece, and then I will export it as a 3MF. I'll give it a name, so I'll just call this one drawer front. And I export it. And I do that so that way when I load this into my slicer, I don't just load every piece because I can only print one at a time anyway. And I can just choose which piece I want to load in, and I'll put this in here and I'll print the one piece. But there we have it. Hopefully you can follow along with this tutorial and it can get you going. And obviously I don't expect you to design this exact drawer yourself, but hopefully you can take some tips and tricks that I did here and show how to go from nothing to something. I know there's multiple ways to do everything in Fusion 360, but hopefully this tutorial can get you guys started in creating your own designs. If you learned something, leave a like. If I can learn something from you, put it in the comments. And remember, if you subscribe, your prints will always come out butter smooth. See you in the next one.